Hello students, we are live. If there is anybody in the chat section, please let me know if I'm properly audible and visible to you. Just give me a quick thumbs up in the chat section so that I can know everything is fine with my stream and we can start our today's session. Give me a quick thumbs. Just let me know guys in chat section. Okay, so guys, in today's session, we are going to discuss variety of questions in machine learning because I have made these questions by myself and picked it from some resources so that you can get the best questions and you would know how to solve gate level questions and how to answer these questions. So we are going to do that in this session. And moving forward, like we'll have 3 sessions of machine learning. I'll make sure that we are going to cover all the algorithms of machine learning and all the basic concepts like cross validation, bias, variance question. So we are going to cover all of that questions in this video, and but make sure that the concepts which we are going to use is clear to you. If that concept is not clear, you can ask me in the chat section. We can discuss a little bit, or I can give you an overview of that. We cannot discuss a whole topic in this session. If you want to learn the whole topic, you can recommend my, like you can go through my previous videos in which I have taught machine learning, right? You can go through that. But in these 3 sessions, that would be Wednesday, Thursday, and Friday, for machine learning, we are going to discuss questions. Okay, and if at any point you guys face any doubt or anything, just let me know in chat section. Okay, so let's start with the questions. And I have this first question. So guys, all of you know what is classification, what is regression. If I have a output variable that is numerical value, right? Or I can say that continuous value. So that is my regression problem. And if I have classes, right? I have output value as categorical value, then that is a classification task. So now in this question, I want to tell that which of the option is, or which of the statement is classification problem and which of the statement is regression problem. Okay, so that's what we are going to solve in this. So you can see here, a company wants to launch a new product and wants to know whether it will turn out to be a success or failure. We have information on the last 100 products this company launched, including if it was a success or failure, price, weight, color, several other variables. So just tell me guys, is it a classification or regression problem? So you can see here that because you have output value either success or failure, that a particular output is going to be a success or a failure. So that's why this is my classification problem. Classification problem. And if I'll see next question, we have information on several Bay Area tech companies, including size, industry, revenue, average employee salary, and more. We want to know which features influence the average employee salary, right? So what is the output here? Which features influence the average employee salary? So that means we are going to classify, right, which feature is important, right? So that is because we are giving feature, so that is a classification task again. Next question, you are given data of 100 individual and their sequence DNA, want to know whether these individual will exhibit a particular disease based on their genomic mutation. We have information on 10,000 individual genomes, whether or not they exhibit the particular disease. So that means they are going to have a particular disease or not. So this is again a classification task. Right? So these two are simple, first and third. But if you would talk about second, which one is regression? Revant, can you tell me that for which option you have answered the regression? If you would see second option, they are asking that we want to know which features influence the employee salary. So this is a dimensionality reduction problem, right? This is a dimensionality reduction problem, and in this dimensionality reduction, because we want to know the features, that means I want to classify that which feature is important. So in this, we have to find out that which feature is important, which features influence the average employee salary, right? We want to find out the features here. Okay, so let's see next question. So this is the next question. You are given reviews of few movies marked as positive, negative, or neutral. Classifying reviews of a new movie is an example of, if I have to classify movie as positive, negative, or neutral, that is again a classification task. But they are asking for supervised, unsupervised, semi-supervised, and reinforcement. So obviously it is supervised learning. What is the difference between supervised and unsupervised? Supervised, we have an output value. In unsupervised value, we have unlabeled data, right? In supervised, we have labeled data. Unsupervised, unlabeled data. And semi-supervised is mixture of supervised and unsupervised learning. Reinforcement learning, when we'll train an agent based on the, like the computers would play the game and would learn by itself. Then we have reinforcement learning when we do not have any data. Okay. Right, Ajay, Revant. Okay, so here option A is correct. Guys, this is another question. Imagine a newly born starts to learn walking. It will try to find a suitable policy to learn walking after repeated falling and getting up. Specify what type of machine learning algorithm is best suited to do the same. So guys, you have seen that the starting questions are a little bit easy, but we are going to, moving forward, we are going to discuss more questions in detail. What type of machine learning? Because a newly born starts to learn walking, right? So that means the newly born would learn by itself, by its mistake and by award and punishment policy. So that's why this is my reinforcement learning. So option C is correct, right guys? Option C is correct. This simple question. Next question is, classify the following as regression or classification task. Predicting the outcome of a election, obviously it is classification. I want to classify that the person is going to win or lose. Predicting the weight of a giraffe based on its height. Regression, because weight is numerical value. Regression. Or I can say that continuous value. Predicting the emotion conveyed by a sentence. So emotion can be categorical. Happy, sad, like this, right? So that's why this is again classification. This is not a numerical value. Predicting the temperature for the next day. Obviously it is regression, because I am going to predict a numerical value. Temperature is numerical. Detect pneumonia from chest x-ray image, right? So if I want to detect pneumonia from x-ray image, right? So that means I am going to say that the person has pneumonia or not. So that means this is my classification task, right? So this is simple. These points are simple. I hope this thing is clear. Guys, if anybody face any confusion, you can just let me know in chat section. So guys, this is a question. Consider the following training set of m is equals to 4 training example. Consider the model regression, linear regression model, y is equals to wx plus b. What are the values of w and b you would expect to obtain upon running gradient descent on this model? So guys, what gradient descent does? Gradient descent makes the minimum value of my cost function. Find out the minimum value of my cost function. And what cost function consists of? Cost function consists of 1 upon 2n summation I varying from 1 to n y cap minus y whole square, or yi minus y square, right? This is my cost function. So your linear regression, or you can say that the gradient descent, find out the minimum value for this function. But if I'll see this, I can see that what is happening here. What is linear regression model? They have given the linear regression model is wx plus b. So you can see that the values are getting half. 1 gets 0.5, 2 gets 1, 4 gets 2, and 0 gets 0, right? So that means values are getting half. So can I take the value of w is equals to 1 by 2 and b is equals to 0? So by writing the model x by 2, right, what is happening? I'll get the minimum error. I'll get a 0 error. I can say that even I'll get a 0 error, right? So that means there is no value which is less than 0 for the cost function. I cannot have any value that is negative, right? So minimum value is 0 for this cost function. And because this function is giving me 0 error, why it is giving me 0 error? Let's suppose this is your y cap, and if you would find out y cap, 1 divided by 2, 0.5, 2 divided by 1, 1, 2, 0. You can see the difference between this and this is 0, right? So you would have cost function value 0. So now you can say that your option C is correct, B0, W 0.5. And you can also check all the options, right? What you can do, let's suppose you are not able to find out directly that what value of w and b you would take. So you would take each of the function, find out the value of cost function, and see that which of the values of w and b gives you the minimum value for the cost function. That would give you the correct answer. Why w? Because I can see here that Revan, you can see that what is happening in my data set, values are getting half, right? Values are getting half, 2 becoming 1, 4 becoming 2, 1 becoming 0.5. So obviously I can do half by multiplying w, by taking w1 by 2. Then y is equals to x by 2, and I have to take the value of these as 0. Okay guys, let's go through it once again. So these are my x value, these are my y values. I have given these 4 options, 1, 2, 3, 4. And they are asking that find out a model y is equals to wx plus b. I have to find out a model wx plus b such that my gradient descent running on this model. And what gradient descent does? Gradient descent find out lowest, or I can say that minimum value for cost function, lowest value of cost function, right? You have to find out lowest value of cost function. So what would you do? So let's suppose first you would define that your y cap is, you are taking value w0 p.5, right? If I'll take this value, so you would get 0.5 as your function, w into 0 into x plus b, that is 0.5. So that means option A, y cap is 0.5. So for every value of x it is 0.5, right? So if you would find out the error, what is y minus y cap? If you would find out the error, y minus y cap, 0.5 minus 0.5, 0, right? 1 minus 0.5 plus 0.5, or you can say that instead of taking, let me say that I am taking here y minus y cap, right? What would happen? And I'm also taking a square. 0.5 minus 0.5, 0. 1 minus 0.5, 0.5. That means 0.25 if I'll take a square. 1.5, that would give me 1 point, or I can say that it would be 2.25. 2.25, and this is a difference 0.5, that means 0.25. If I'll take a sum of all these values, what it would give me? It would give me 2.75. So if you would find out your cost function value, what is cost function? 1 by 2n summation I varying from 1 to n y minus y I cap square, right? This is my cost function. If you like, you can see that y minus y cap square summation I got as 2.75. So 1 by 2 into 4 into 2.75. So you can see that it would give you the value 2.75 upon 8, right? It would give you the error 2.75 upon 8, right? That's what I'm telling Revan. So you can see that I get the error 2.75 by 8 for option A. So in this uh, cost function value is 2.75 by 8. What would I do? I'll solve for B part. For B, it would become y cap is equals to 0.5x plus 0.5, right? You would solve the same thing for B part, and you would find out your cost function value. Similarly, you would find out cost function value for C part. But in C part, what happened? Your cost function value gives you 0, and neither other option gives you 0, right? So only option C gives you 0. That is a minimum value, right? That's why I'll say option C is correct. Now let me know if this thing is clear, that if it is not exactly half, then how would you solve the problem? Then you would see that which of the option giving you minimum value for the cost function. Now let me know, Revant, if this thing is clear. Just let me know guys in chat section if this problem is clear, so that we can move to next question. Or if there is still an doubt, you can ask. Okay, great. So let's move to next question. So guys, this is a question. Just think about it. Which of the following offsets do we use in linear regression? Least square line fit. Assume the horizontal axis is independent variable and vertical axis is dependent variable. This is vertical offset. This is perpendicular offset. Can you tell me that which of the offset we use? Which of the offset we use? What is the offset basically? So you know that if I have this data set, right, if I have this data set, I have this linear regression problem. So this is my exact value and this is my predicted value. For this particular x, predicted value is this y cap and this is my actual value. So I'll take a difference that is vertically, right? I'll take the difference vertically. So this is vertical offset. Option A is true here, right? So we use in linear regression, we use vertical offset. This perpendicular offset basically uh, we use in dimensionality reduction in PCA, right? We are going to discuss that in PCA question. Like there is one question which based on PCA, perpendicular offset we use in PCA, where we find out perpendicular, like the direction in which we have maximum variance in PCA, principal component analysis. Okay, so here option A is correct. Now let's move to next question. This is a question: which of the following is if any is a valid cost function in a regression setting and why? Can you tell me which of the following is valid cost function of ABC? Out of ABC, which I can take as valid cost function, which can define my error? Tell me guys in chat section. See guys, in this question I have two options correct. Option A is correct because this is my mean squared error. Option C is also correct because this is my mean absolute error, right? Option B is not correct. Now you would say that, ma'am, why option B is not correct? Because if you are saying A and C are correct, why you are saying that option B is not correct? Can anyone tell me that why option B is not correct? Because I told you that the linear regression problem, you find out the best fit line, right? Let's suppose this is my data set and I find out this best fit line. If I'm taking cost function as, let's say cost function as y minus yi minus y, okay, this is y cap, right? This is fwx, they have written as y cap. So this is y cap minus y. If I'll take this and I'll take a summation 1 by 2m, but if you would see, this would give you positive, you can see that your predicted value is less than your actual value, so this would give you negative value. And because here you can see that this predicted value is greater than your actual value, so this would give you positive value, right? This would give you positive value because it is y cap minus y. Now you can see that if you would take a summation, positive negative cancel out itself, and they are not going to they are not going to understand the actual error, right? Because positive and negative cancelling out each other, right? So that's why option B is not correct, but option A and C are correct. Okay, now let's move to next question. Okay, which statement is true about outliers in linear regression? Linear regression is sensitive to outliers, not sensitive to outliers, can't say none of these. Ajay, basically what happened when we apply gradient descent, right? You can also write, you are also right that you can take 1 by m, but when we apply gradient descent, we just find out the differentiation for your cost function. And in that, if you would differentiate x square, what would happen? It would give you 2x. So only for just simplifying, we have divided by 2 because 2 and 2 get cancelled. But 1 by m is also correct, right? So both are correct. Now, which statement is true about outliers in linear regression? Linear regression is sensitive to outliers or not? Obviously, linear regression is sensitive to outliers, right? Why is that? Because you would say that, let's suppose this is your data set, right? This is your data set. If you find out a best fit line, it would be something like this. But let's suppose if you have a outlier, if you have one point here, then your line slightly deflect from the best fit line. So that's why we do not use outliers when we do not use linear regression when we have so much outliers in our data set, because line actually deflect from its data from the best fit position. Okay, so here option A is correct. Okay, guys, this is important question and actually a gate level question, right? So they are saying that suppose L1, L2, and L3 are three learning rates for ABC respectively. Which of the following is true about L1, L2, and L3? So here you can see that, guys. Let me make you understand that what this graph says. So this is saying this is J theta is my cost function, right? As number of iteration increasing, this J theta, the cost value or the error function decreases like this. In option B, and in this case, I have learning rate L1. In this B, I have learning rate L2 and cost function decreases like that if I increase number of iterations, right? Because a gradient descent is iterative method, right? And in this case, L3, a number of iterations increases, then your cost function value is increasing. Can you tell me? Can you tell me which of them gives the true relation? Tell me, guys, in chat section, which of them is true? Think about it and let me know, guys, which of the option is true here. See, what is learning rate? Basically, learning rate is, let's suppose you have to find out the value of W, right? So how do you find out W value? W minus using gradient descent. Del L, or in this case, I'll write down del J. Del J by del W, right? So this eta, here this I'm taking here eta. So eta represents learning rate. Learning rate. Guys, understand this carefully. So if this eta is too high, if this eta is too high, and let's suppose this is your curve, this is your cost function, you would try to reduce the value of your, like, of your cost function. Let's suppose this is a curve, that is your cost function, that is J, right? You try to reduce the value. So what would happen? Because if eta is too large, so you would actually find out the value of W. So there might be a possibility that it would move like that and it would never goes to minima, right? In this case, eta is very large, right? If eta is very small, eta is very small. If eta is, in this case, I am talking about large eta, and in this case I'm talking about if eta is very small, if it would reach to minima, but it would take very small steps to reach to minima, and it would take so much iteration to reach to minima. It would eventually reach minima, but it would take too much time. So that's why I cannot take eta too large and I cannot take eta too small, right? I have to find out middle value. So now you can see that in this case, L3, because your, when you are increasing number of iteration, your error value is increasing, right? This J value is increasing, right? So that means in this case, L3 is maximum, right? L3 is maximum in this case. So L3 is maximum. And you can see that now the question arises for L1 and L2. So you can see that in this L1, we have a best L1. You can see that because it reaches to minima and as at up to this iteration. But in this L2, it decreases very slowly, right? This, your error function decreases very slowly. So you can say that L2 is very small, L1 is larger than that, and L3 is too large. So option A is correct. Right, guys. Rushikesh, Faizan, Akhil. Yeah, option A is correct in this. Right, so I just hope you guys get it that why option A is correct. Just let me know if there is any confusion in this question. Let me know, guys, in chat section if there is any confusion at all. That why option A is correct. Just let me know. Okay, so I assume everyone gets it. Now, the next question here is, consider the following data where one input X and one input Y. What would be the cost for this data if you run a linear regression for this model? And the linear regression model is Y is equals to WX plus B. Can you tell me what would be the cost function? What would be the cost for this data? Let me know, guys, what would be the cost for this data if you run a linear regression model here. So guys, see, this is a your data sign. Your data is linearly linear. This data set is linear data, right? If you would find out a line, you would find out this line, and this line would be like captures all the data points, right? So you do not have any error here because all points, all data values given you in a line. So that's why it is equals to 0. So option C is correct. I hope you guys get it. Right, Akhil. Option C is correct. Okay. Now, this is a simple question. Uh, Guys, it cannot be option A because error function cannot be less than, take value less than 0. Because if you would talk about cost function, I told you it would be summation yi minus yi cap square 1 upon 2m. I varying from 1 to m. So you can see that there is a square term. So there is no negative value. There is always sum of positive value. It either can be 0 or greater than 0. So just remember that cost function cannot take value less than 0. If you are getting the value of cost function 0, so that means the data is linear data. Okay, now let's see next question. This is another question. The selling price of a house depends on following factor. For example, it depends number of bedroom, number of kitchen, number of bathroom, the year the house was built, the square footage of the lot. Given these factors, predicting the selling price of a house is an example of which task? Binary classification, multi-level classification, simple linear regression, multiple linear regression. Let me know. You have to predict the selling price of a house based on number of features. Obviously, it is right, guys. So it is option D is correct. Right, Jaya, Fazan, Akhil. Uh, no, guys, it would be D. Multiple linear regression. Jaya, it would be D. So I hope you guys get it that why D, because we have number of features, right? We have more than one input feature, so that's why it is multiple, and we have to predict selling price. That is a numerical value. That's why it's regression, linear regression. Let's see next question. Okay, the answer is visible, but let's solve it. Your team is working on a regression problem, and you observe that the model has a high mean squared error on a training set, but a relatively low mean squared error on the test set. Which of the term best describe this scenario? Tell me, guys. Which of the following term best describe this scenario? High bias, high variance, low bias. Ajay is saying that it can also be multi-class classification. See, because you have to predict selling price of a house, right? And price of a house is numerical value, right? It is not categorical. If output is categorical, then it is a classification problem. Otherwise, it is a regression problem. So it is a regression problem because we are predicting numerical value or continuous, or I can say continuous value, not. So yeah, this is a question. Your team is working on a regression problem and you observe that model has a high mean squared error on training set, but a relatively low mean squared error on the test set. Which of the following term best describe this scenario? Right, Ajay. We can also, yeah, we are going to come to this question, Ajay. I have this question already added in my slides. Ajay is saying that we can also use KNN for regression. Yeah, we can use K nearest neighbor for regression. I'll give you an example. But yeah, we can use KNN for regression as well. But we generally do not use KNN for regression because KNN is lazy learning problem. There is no training algorithm. We just have, like in training time, what you do, you would load the data set only, right? You do not have to do nothing. Everything is done in the testing process. So guys, we are having relatively low mean squared error on test set and high error on training set. Obviously it is a high variance problem, right? Your data, like your model is going to is over yeah, you have high variance because you it is not learning the training set, it is only like but a relatively low mean squared error on the test set. No, this is not a overfitting problem, guys. This is not a overfitting problem. Right, Fizan. This is not a this is not a this question has some problem, guys, because you are getting high mean squared error, so you can have high bias, and relatively low mean squared error, like it can have high bias, sorry, low bias, high bias, high error or training set, right? It can have high bias, right? And it is just a like coincidence, right? You cannot say anything. So this question is not proper. Let's move to next question. Revant is saying option A is overfitting means low bias, high variance. Right, Ajay. So that's why I said that this is not a overfitting, right? Because in this we are getting high bias, and on output data set we are getting low value of the error. Acha, Ajay is asking overfitting means low bias and high variance. Yeah, overfitting means low bias and high variance. Underfit होगा high training error पर. Right. So it can have answer high bias. Right. Option B is not correct here. Okay. Let's move to next question. This question has some error. Suppose you got a situation where you find that your linear regression model is underfitting in the data. In such a situation, which of the following option would you consider? You will add more feature. You will start introducing higher degree features. You will remove some features. None of the above. What would you do? What would you do, guys, in this case? Your linear regression model is underfitting the data. So you can do both A and B. You can add more features and start introducing high degree features, right? Both would help you solving the problem of underfitting. So here option A and B both are correct. Guys, B is also correct in this. Right, B is also correct here. Guys, B is also correct. B is also correct. Option A comma B. Now let's solve next question. You have generated data from a 3-degree polynomial with some noise. What do you expect the model was trained on this data using a 5-degree polynomial as a function class? You have generated the data from a 3-degree polynomial with some noise. What do you expect of model that was trained on this data using a 5-degree polynomial as a function class? Just tell me, guys. In this question, you have generated data. Like, what would be the comparison of a 5-degree polynomial? Just let me know in chat section. Here option A would be true. Why A would be true? Because 3-degree polynomial, when you are taking 3-degree polynomial, let's suppose you have taken W1x, or let's say Wx plus B, or sorry, W1x, let's say 3-degree polynomial you have taken, na? W1x cube, W2x square plus W3x plus B, right? This is your first 3-degree polynomial. And if you would take 5-degree polynomial, it would be W1x to the power 5, W2x to the power 4, W3x to the power 3, W4x square, and W5x plus B. This would be your model, right? Now you can see that in this 5-degree polynomial, it would try to fit more on the data, right? Because of this 5-degree polynomial. So you would have less bias in this case, less error on the training data, right? And when it has less error on the training data, that means it tries to fit more on the training data because of this higher degree features, right? Higher degree features, it would try to fit more on the training data as compared to fit on a, like, as compared to give good results on testing data, right? So it would vary more if you would take different subsets of the data set, and it would give you different results on different data sets. So that's why you have less bias and more variance. You can say that high variance. Basically in this case you just have to write more variance, less bias and more variance, and less bias and more variance as compared to this model, right? Do you get it? Do you get it, guys? So here option A is true, low bias and high variance as compared to 3-degree polynomial. So 5-degree polynomial has low bias and high variance as compared to 3-degree polynomial. Just let me know if this thing is clear. Let me know, guys, if this thing is clear. Let's move to next question. Okay, yep, option A is true here. So this is another question. Select all the following reason why we would use lasso over ridge. So guys, I hope you know what is lasso regression and ridge regression. Can you tell me what is lasso and what is ridge? Right. If I'll take higher degree, right? If I'll take higher degree, so you can see that if you would take y is equals to wx plus b, right? What would happen? You would get a line. Just give me a minute. If you would take y is equals to wx plus p, you would get a line. If you would take w1x square plus w2x plus p, that means you are getting you are taking 2-degree features, right? Features of 2 degree, you would get a polynomial. And if you would take a cubic feature, you would add cubic feature, you would get a graph something like this, right? If you would take x to the power 4, the graph would become more complex, right? So that's why if you would increase the power, your graph would become more and more complex. So it tries to fit the data more, right? So let's suppose we have this data set, right? If I'll take a very high degree polynomial, so what would it would do? It would try to fit the training data more, right? So in this case we have very less bias, very less bias. But this data set, this model, what this model would do, this would provide you high variance, right? High variance. And this is a case of overfitting. Less bias, high variance. This is a case of overfitting. Overfitting. Let me know if this thing is clear. Just let me know, guys. Let me know. Right, Riche. It not tries to like basically it tries to like actually fit my data set. Okay, so let's see what was less lasso do. Lasso tells us in this lasso we'll add a hyperparameter, that is lambda, and modulus of wi, right? This is for lasso, this is for lasso. And for ridge, what would we do? We'll add wi square, right? This is lambda is my hyperparameter, this is ridge. So the difference between lasso and ridge, that in lasso we have some values of wi 0, but in rich it would approximately 0, like it would get closer to 0, but it would not remove the features, right? So you can see that Lasso help us which features are important, because it would reduce number of features. It would take for some of the wi's, it would take some of the wi's to 0, right? And remaining wi's you can use, like let's suppose in you have w1 w2 w3 w4, you have 4 wi's, right? You have 4 features and you have used 4 w's for, like you have this model w1 x plus w2, or let's say x1 w2 x2 w3 x3 plus w4 x4 plus b, right? You have 4 features here. What Lasso does, Lasso would make sum of the wi 0, right, by adding this lambda modulus wi to your cost function, right? So let's suppose w1 w2 get 0, right? So in this case that means x1 x2 features are not important, I am just predicting based on x3 and x4 feature. So Lasso is doing that. But rich, what rich does, it would reduce the values of wi, but it would not take all exactly value of wi as 0, right? So that is the difference. So it can help us identify which features are important. Option B saying it is faster to learn the weight for Lasso than for regression. That is not true, right? There is not a learning match here. Lasso usually achieve lower generalization error than rich. Obviously, Lasso would have less generalization error because it is making some of the wi's as 0, right? So option C is true. If there are many features, the model learned using Lasso can make predictions more efficient. Guys, we cannot say that if there are more number of features, then we have efficient results using Lasso, right? There may be a possibility that all the features are important, right? What Lasso is doing? Lasso is reducing number of features. It would making some of the features as 0. But we cannot say that every time we have a model something like that in which we have to reduce number of features and it would give efficient result. There may be a possibility that if I have n number of features and I have all n features are important, I cannot remove those features. So that's why I cannot say that this Lasso make predictions more efficient, right? So option D is incorrect. So here only option A and C are correct. I hope you guys get it that why option A and C are correct. Let me know if there is any confusion in this. Guys, ma'am, low generalization error means, so basically generalization error, that means we are getting error on like general error, right? What is my training error plus test error? That is generalized error for both the values, right? That is your generalization error. Okay, now let's see next question. With Lasso regression, the influence of hyperparameter lambda, as lambda tends to 0, the solution approaches to, as lambda tends to 0, the solution approaches to. Guys, if lambda would become 0, let's suppose your model is w1 x1 plus w2 x2 plus let's say w3 x3 and it goes up to wn xn plus b. And in cost function, what you have done, in cost function you have added, like you have your error yi, and I'm not writing this whole, I'm just writing mean squared error, and I am adding lambda with summation modulus of wi, right? And if this lambda becomes 0, if this lambda becomes 0, what would happen? Let's say this lambda becomes 0, your this whole value would become 0. Now cost function is equals to minimum squared error, so there is no impact on my model, right? It would work simply as linear regression, what we have done previously, right? So it would not never go to 0 1 or infinity, it would be a linear regression. If lambda would become infinity, see guys, if lambda would become infinity, let's say lambda you would take up very high value, so wi, all the wi's would become 0 because cost function I have to reduce. In this case your model would become a constant b, right? And if you have taken this b as 0, your solution approaches to 0, right? So that's how you can understand. Right, Revant. I hope this thing is clear. Let's move to next question. Suppose you fit both ridge and lasso regression on models to a dataset with 100 features. After fitting, ridge regression selects 100 features, while lasso regression selects only 20 features. What inference can be made about level of multicollinearity in the dataset? Tell me, guys. Answer will be linear regression. C. Yeah, just tell me in this. See, guys, what is happening here? What Lasso does? Lasso reduces number of features, right? And on what condition Lasso reduces number of features? It would pick the features which are more important to our to our model, right? Selects, and in this question, Lasso obviously ridge do not decrease number of features, so it has selected all the features, 100 features. But Lasso has selected only 20 features. So what would happen? So when I have number of features, let's say I have 100 features, and based on that, I am predicting an output. I am predicting an output. So that's why I'm saying that out of these features, out of these 100 features, I have selected only 20 features. That means Lasso is suggesting us that these 80 features are not important to us, right? So that means there may be a possibility that there is a possibility that these three features are collinear. Collinear means that means they are linearly related. So that means, let's suppose if I'll take size of house, and here I'm taking length of house, length of house. So you can see that they're collinear. As length of house increases, size of house also increases, right? So instead of taking these two features, I can what Lasso does, Lasso can take only one feature out of these two features, right? Lasso can do that. So that's why when Lasso is reducing number of features, so we can inference that it has my data set has high collinearity, right? So that's why I can have here high multicollinearity in my data set, because Lasso is reducing number of features. Okay, just let me know, guys, if there is any confusion in this. If not, let's move to next question. In the Lasso and ridge regression, as alpha value increases, the impact on slope is either I can say alpha or lambda. Lambda, same thing, right? That is my hyperparameter I'm talking about. What would happen, guys? Increases the value of alpha, increases the value of lambda, the impact on the slope is what would happen? Tell me, guys, what would happen if I'll increase the value of lambda? See, what I am doing, I am taking my cost function and I am adding mean squared error with, let's say, either I have Lasso or ridge, I am just adding lambda summation wi, modulus of wi, or I am adding lambda summation wi square, right? I am adding these two. In Lasso, I am doing this, and in ridge, this. But if I'll increase the value of lambda, let's suppose I am increasing the value of lambda, then wi decreases, wi decreases. And what is wi? If I'll talk about linear regression, wi is my slope, right? If I'll take a particular line, y is equals to wx plus b, right? That means if value of w is decreasing, what would happen? Your line would move towards x-axis, right? So that means alpha value increases, the impact on slope is slope of regression line reduces and become horizontal. Option B is true, right? Just let me know if there is any confusion. Let me know, guys, if there is any confusion at all. Okay, let's see next question. Okay, so from this question onwards, From this question onwards, we have questions based on overfitting and cross validation, underfitting, bias, variance. So just go through once, just go through the concepts of bias, variance, underfitting, and overfitting once. And from in tomorrow class, we are going to cover all those questions based on that. And also, we are going to work on KNN. And if we left with time, we are going to cover naive Bayes algorithm as well. Right? So we are going to solve so many questions. So you can join the class at 5 p.m. for machine learning, for gate data science. We are going to solve questions and we are going to learn that how to work on this. And like you can share the questions with, share this lecture with your friends as well. And before moving forward, guys, if you have learned something from this, so please like the session. We are going to continue in the next session because I have only 1 hour time. Yeah, Ajay, tell me what doubts you have. Just tell me, guys, if you have any doubt. If there is MSQ, Ajay, they do not say that this question, this particular question is MSQ. What would they say? That which of the following options is slash are true? Then you have to decide that this question is MSQ or not. So in GATE exam, you do not have a particular section that this section contains MCQ, this section contains MSQ. So that's why you have to understand the question's language. That if they have used the word is slash are or options, so that then you have to go through that. It would be MSQ, right? Yeah, gene index is a part of syllabus, right? If you haven't gone through, like I have taken already session on decision tree, so you can go through that, right? We have discussed in detail that topic. Now let me know, guys, if there is any question. Otherwise, we are going to continue in the next session. Okay, so that's all from my side, guys. Thank you for joining. And moving forward, before moving forward, please like the session so that it can reach to more students and we can help more students as well. Okay, so thank you for joining.